right, everyone, we are back, and so we are going to solve this problem using our static equilibrium conditions that sum of the forces must be equal to 0, and that means the sum of the forces in the x must be equal to 0, sum of the force in the y must be equal to 0. So first step, we have our coordinate system, we have our sense of positive and negative x directions and all of those good things. So now we have to resolve the forces. We have these two fundamental equations. We have two unknowns. What is the force 1? What is the force 2 magnitude? So let's go ahead and set that up. So we know sum of the forces in x equals 0 equals our F1 that's unknown times cosine of 40 degrees. And then we'll do minus F2 times cosine, of 11 degrees plus F3 times cosine of 29 degrees. Set that equal to 0. Sum of the forces in the y must be equal to 0, which is equal to F1 sine of 40. And then it's going to be plus F2 sine of 11 degrees minus F3 times sine of 29 degrees. And then set that equal to 0. So that's great. I am going to go ahead and go to evaluation. I'm going to quit my kernel here to clear all my variables. And I'm just going to reset things. So I'm going to say we don't know what F1 is. We don't know what F2 is. But we know that F3 is equal to 170. So I'm going to redefine that. I also know that my first is 40. Then it's 11. Then it's 29 degrees. F1 cosine minus plus. Excellent. So I'm going to call this is going to be equal to my equation 1. Well, actually, we'll keep it as that. Sum of the forces in the x direction. And then we're going to say that this is our expression. And we're going to say double set, this is equal to 0. So this whole equation, this variable here, this equation, frx, is going to be equal to 0. And we're going to do the same thing. Fy is looking fine. And we're going to set this equal to 0. Oops. Let's go ahead and define everything. I'm shift entering, by the way, as well. So we have two equations that we've set equal to 0. And we need to solve for two unknowns. Now, obviously, you could rearrange equations. You could do math. You can make sure that you could do this. But F1, F2, two equations, two unknowns. So I'm going to solve these two equations like so. Frx and then Fry. And let's go ahead and solve this numerically. And there we go. So we've got it. And again, you could substitute, you could do lots of different mechanisms in order to reduce that, but that's our solution. Fantastic. So we'll see you in the next video when we get into a very, very important concept, which is called moments. So we'll see you then. Thanks. Bye.